Good afternoon. Today I am going to start the first chapter's topic, propositional logic. So let's begin with propositional logic. The phrase propositional logic, it is made up of two words. So for the first is propositional and the other is logic. So let's leave proposition for now and focus on the word logic. What do you mean by logic? Logic, it is basically giving some kind of reason. So logic is the science of reasoning. So it is giving some kind of reason, and it helps us to understand and reason. It helps us to understand and reason about mathematical statements. So we study and understand and reason mathematical statements. With the rules of logic, we would be able to think of mathematical statements and we can prove or disprove. So basically, with the help of logic, we usually prove or disprove mathematical statements. So mathematical statements are proved or disproved with the help of logic. Now, the purpose of logic is to create valid arguments. So the purpose of logic is to create valid arguments. And once we prove that a statement is true, a statement is proved as true, we call it a theorem. Okay. So this is what logic does. So in our case, propositional logic, we have to understand that it is reasoning and understanding of mathematical statements. It proves or disproves some kind of statement, and the purpose of logic is valid arguments, and whenever the statement is proved, it is known as a theorem. And this entire concept is the basis of mathematics, correct? So the entire concept is the basis of mathematics. Now, propositional logic, the entire term, it is an area or a branch of logic. So it is an area of logic. Now, let's move on to what is a proposition. So for that, a proposition is a declarative sentence. It is a declarative sentence, and which is a sentence that is declaring a fact or stating an argument or stating an argument. Okay. Any statement which is a fact can be known as a proposition. Also, one more property of a proposition is that it can either be true or false. So the proposition should either be true or false, but it cannot be both. Okay. So by the definition, a proposition is a declarative sentence, a sentence that declares a fact which is either true or false. Now, let's see a few examples. First, we have to check, are the following sentences proposition? So Hyderabad is the capital of Telangana. Now, can you tell me whether this statement is true or false? Just think about it. So if you know that this is true. Okay. So if this is true, then this can be a proposition. Okay. This is true and it is a proposition. Read this carefully. Now, can this statement be either true or false? No, it cannot be true or false. Hence, this is not a proposition. Okay, next. 1 plus 2 is equal to 3. Is it true or false? It is true. So, this is a proposition. Next, x plus 1 is equal to 2. In the case of x plus 1 is equal to 2, we do not know the value of x. X value is unknown. In the case it is unknown, if you take x is equal to 1, the statement might be true. If you take x is equal to 2, the statement might be false. But since we do not know the value of x, we cannot tell definitely whether it is true or false. In this case, we say that this is not a proposition. Now, the next thing, what time is it? What time is it? It is a question. It is not a fact. So in this case, this is also not a proposition. So if you see, I have written yes or no. So Hyderabad is the capital of Telangana. Is it a proposition? Yes. Read this carefully. It is not a proposition. 1 plus 2 is equal to 3. It is a proposition. X plus 1 is equal to 2. It is not a proposition. What time is it? It is also not a proposition. Next. Now, all the following declarative sentences are propositions. So in this case, we already know that the sentences given are propositions. The four statements that have been given are propositions. Also, I will say what P, Q, R, S are in the next slide. So these things, I'll explain it in the next slide. For now, just see the statement. Jane Austen wrote Wings of Fire. Now, in this case, if you know anything about books, you will know that Wings of Fire is a book written by our ex-president APJ Abdul Kalam. Now, so the statement is false. Okay, so it is false. Now, and since we can definitely say that it is false, it is a proposition. Next, New Delhi is the capital of India. The statement is true. And since we can definitely say that, it is also a proposition. 1 plus 1 is equal to 2. It is true. It is true, and for that reason it is also a proposition. 2 plus 2 is equal to 3. It is false. So since we can definitely say that it is false, it is also a proposition. Now, some sentences that are not propositions are given below. Now, what time is it? Can we say whether it is true or false? No, so it is not a proposition. Read this carefully. The same thing, we cannot tell whether it is true or false. It is not a fact. It is an order or a request. So we cannot say whether we are supposed to say it is not a proposition. X plus 1 is equal to 2, x plus y is equal to z. In both the cases, x, y and z values are undefined. So all of these are not proposition. So the same thing. Now, the next thing, just revise these statements. Propositional logic, the area of logic that deals with propositions. Now, as I said earlier, we will look at what those PQR were. So PQR that I mentioned in the last slide, these are known as propositional variables. So these are propositional variables. Variables that represent propositions. So every time if you write some fact and you want to express it in propositional logic, you take a small letter, a small alphabet, a lowercase alphabet and represent it. So example, today is Friday, we are representing it with P. In the earlier slide, the same thing, as I said, I'll revise it later. P, the proposition P is Jane Austen wrote Wings of Fire. The proposition Q is New Delhi is the capital of India. R is 1 plus 1 is equal to 2. S is 2 plus 2 is equal to 3. So all of these four things, P, Q, R, S over here are known as propositional variables. Every time I'm writing a proposition, I'll denote it with the variables. Also, these are very important when we create something known as the truth table. Now, now, every proposition has two values. It can either be true. So today is Friday. This statement, if it is Friday, it will be true. If it is not Friday, it will be false. So every proposition has two values. Those are true and false. And the next thing, compound proposition. Compound propositions are something which are joined propositions. So if you are joining two propositions, then those are known as compound propositions. So whenever we join two propositions, suppose I want to join P, Q, there are four logical connectives. So there are connectives to join propositions. Actually, in total, there are six logical operators, but connectives are five. So there are total six logical operators. We will study it further, but let's just see an overview. So connectives. So whenever we have two propositions, we join them by connectives. So the connectives are denoted by these symbols. First one, it is negation. This is actually a unary operator, so it works only on one proposition. The second one is and, the inverted V. Third is or. Fourth is exclusive or sometimes we call it as XOR. Fifth is implication or conditional. And the sixth one is by implication, by implication or biconditional. We'll study all of them in detail in the next slides, but for just an overview, compound propositions are something when we want to join two propositions, then we use something known as connectives or logical operators. Connectives are when you are joining two propositions, so negation, it is not a connective, it is a unary operator. Next, let's begin with negation. So the definition for negation is, if P is a proposition, then the negation of P is denoted by the symbol which is given over here. Or normally whenever I am using negation while teaching, I will use this symbol. Okay. Or even sometimes in some books we use this, a bar above P. Okay. And the negation of P denoted by this symbol or even this symbol is, if you write this negation of P, that is read as not of P, not P. Or sometimes it is also read as it is not the case that P. Okay. So whenever we have a proposition, if we apply negation to it, we have to attach this part of the statement. It is not the case that P. The proposition negation P is read as not P. The truth value of the negation P is opposite of truth value of P. So suppose if the truth value of P, the proposition P is true, then negation P will become false. If the proposition P is false, then negation P will become true. Okay. Now, example, find the negation of the proposition today is Friday. So the statement P is today is Friday. So this can be expressed today is not Friday. So you just have to attach the word not here, or it can also be said that it is not the case that today is Friday. The next statement, find the negation of the proposition at least 10 inches of rain fell today in Hyderabad. So the negation of this statement will be at least 10 inches of rain did not fall in Hyderabad. Or it is not the case that 10 inches of rain fell today in Hyderabad. Let's see the answers. The negation is, it is not the case that today is Friday, or in simple English, today is not Friday, or it is not Friday today. So you can write the statements in simple English also. There's no issue with that. And you can simply take the word not and write it in your statement. Same with the other solution. It is not the case that at least 10 inches of rain fell today in Hyderabad, or less than 10 inches of rain fell today in Hyderabad. Now, the truth table for the negation is, so every time we take a truth table, you have to understand that a proposition P can have two values. One can be true, other can be false. So a proposition P can have two values. The values are true and false. So whenever we are taking a proposition by itself, it will have two values. It can be true or false. Then in that case, the negation of P will be false, and here when P is false, negation P will become true. Okay, so let's just see it again in the table. P, if it is true, negation P will become false. P, if it is false, negation P will become true. Also, logical operators are used to form new propositions from two or more existing propositions. The logical operators are also called connectives. Okay. Now, so we have seen negation. Next will be conjunction. So conjunction, or we can also call it as and. So in this case, let P and Q be the proposition. So in the case of conjunction, conjunction is a connective. So connectives are used to join two statements. So here we will be joining the propositions P and Q. The conjunction of P and Q denoted by P and Q. Let me write it over here. It is denoted by P and Q. So the symbol denotes and. The inverted V denotes and. Remember it carefully because this is important in the entire chapter. Is the proposition P and Q. The conjunction P and Q is true when both P and Q are true. So, for the conjunction to be true, P should have the truth value true, and also Q should have the truth value true. In that case, P and Q will be true. So let me just change this to equal to the symbol. I'll change the arrow to equal to, because we have another symbol of this way. Okay, so when P is equal to true, Q is equal to true, then P and Q is also true. Next, let's see an example. Find the conjunction of the proposition P and Q, where P is the proposition today is Friday and Q is the proposition it is raining today. So let's write it below. P, today is Friday. I'm just writing as Q, it is raining today. It is raining today. Okay, now in this case, today is Friday and it is raining today. I'm just putting an apostrophe so that you can understand the full form. That you have to find the conjunction of the proposition. So every time you are taking two statements and you are supposed to find the conjunction, then you are supposed to add and between them. You are supposed to add and between them. Okay. So today is Friday and it is raining. Or we can have this, the today is Friday and it is raining today. Now, when will this proposition be true? whenever on Friday it is raining, the proposition will be true. Similarly, I can take another example, and the example I'll write it just over here. So P is the sun is out, and Q is it is raining. So P is the sun is out, Q is it is raining. So whenever we want to find P and Q, we have to attach an and between these two statements. The sun is out and it is raining. So if you join these two statements with an and, then you form the conjunction of the two propositions. Now, also one more thing to be remembered which is important is sometimes the word but is used. So sometimes the word but is used instead of and in the case of a conjunction. Now, let's go for the truth table. So according to the definition, what I said was if P is true and Q is true, then the conjunction of these two propositions is true. Okay, so it is written over here. If P is true, Q is true, then P and Q is equal to true. So over here, both P and Q are supposed to be true, then only the conjunction of the two propositions will be true. Now what happens if PQ, P is true and Q is false? So one of them is false. Now if one of them is false, the conjunction will become false. Similarly, if P is false, Q is true, it is still false, and if both of them are false, again this is false. Okay, so the most important point is the one that I have written over here. That is, let me just highlight it so that you will understand. This is very, very important. So P is true. The conjunction P and Q is true when both of them are true. In all the other cases, it is false. Okay. Next, moving on. Disjunction. Disjunction can be written as or. Disjunction is also known by the term or. Let P and Q be propositions, then the disjunction of P and Q denoted by the symbol P or Q. So let me write it over here. It is denoted by P or Q, and we call this term as or. So the inverted V was and, the actual V is or. Okay. Now let's see the rule. The disjunction P or Q is false when both P and Q are false. So this can be said as the opposite of conjunction. So P, when P is false, Q is false, then P or Q is false. And in all the other cases, it is true. Okay. So let's see an example. The same example, today is Friday and Q is the proposition, it is raining today. So I hope you will note it down as whenever you are trying to write it in the term of a compound proposition, better always mention it as in this form. Today is Friday, Q, it is raining today. Today is Friday, it is raining today. Now, whenever you have to write the disjunction, the word that is to be attached between both the statements is or. So you have to write the word or. So the statement will become today is Friday or it is raining today. Now when will that statement be true? The statement will be true when either it is Friday or it is raining on that day, then the statement will be true. So I'll just show you the answer. So the disjunction is today is Friday or it is raining today. You just have to write the word or. And the next thing is the statement will be true on rainy days or Fridays. Okay. Now we have to look at the truth table. Truth table, we have every time. Okay, one more thing that I want to tell over here is when we have a single proposition, when we just have a single proposition, suppose we had in the case of a negation, we just had P and then we were using negation P. So when we have a single proposition, there will only be two cases. That is, the proposition can be true or it can be false. Okay. Whenever we have two propositions and we are taking a compound propositions. So when we have a compound proposition, in that case we will have four scenarios. So both the propositions can be true, one can be true, other can be false. Okay, so if P is true, Q can be false. The other case will be the vice versa case. So if P is false, Q can be true and both of them are false. Okay, so if you notice, if you have one proposition, a single proposition, you will have truth values 2 power 1. If you have two propositions, we will have the truth values 2 square. If you have three propositions P, Q, R, in that case the number of truth values will be 2Q. Okay, now let's see the truth table. If P is true and Q is true, so what did I say about the rule? We will see that rule first. So look over here. P is false, Q is false, then P or Q will be false. In all other cases, disjunction or is true. Okay, so P is true, Q is true. So both of them are true. So in that case, it is true. Now what happens if P is true and Q is false? So here also one is true, the other one is false. The disjunction will be true because the only condition for which we have to check is both of them being false. The next statement is P is false, Q is true. In that case, also the disjunction will be true. The only case in which the disjunction is false is when both of them are false. So this is the only case when both of them are false, then P or Q will be false. Okay, so let's have a recap over here with respect to conjunction and disjunction, because for the ones who are new it will be a bit confusing. So over here, conjunction, and when both of them are true it will be true, all the other cases are false. Disjunction, or when both of them are false it will be false, all the other cases are true. Next, we have something known as exclusive or. Exclusive or, let P and Q be the propositions. The exclusive or of P and Q is denoted by P or Q. So it is denoted by P or Q. Just let me write the symbol here clearly. And this exclusive or is also known by the name XOR. And this is the symbol. And now, what is the rule? It is the proposition is true when exactly one of P and Q is true. So when either P is true or Q is true, the proposition is true. So here, suppose if P is true, and exactly one. So exactly one means one of them should be true, the other should be false. So if P is true, Q is false, then P exclusive or Q, XOR Q will be true. Also in the case of P being false and Q being true, then also exclusive OR will be true. Also in English, we usually say exclusive OR as either or. Okay, so I can give an example. So the example can be taken as I use a pen, or then you can write Q as, so this P, Q can be I use a pencil. So in this case, P exclusive or Q will be I either use a pen or a pencil. Now, let's see the truth table. What did I say? One of them, exactly one of them should be true. So true, P is true, Q is false, it is true. P is false, Q is true, it is true. In the other two cases, when both of them are true, it will be false. When both of them are false, it will be false. Okay. Next, conditional statements. Conditional statements, so the conditional statements are also known as implication. They are also known as implication. Over here, if P and Q are prepositions, the conditional statement is denoted by an arrow from P pointing towards Q, and it is read as if P then Q. The conditional statement is false when P is true and Q is false. So whenever P is true and Q is false, then P implication Q is false. This is the rule to be remembered. Okay, and it is true in all the other cases. So it is true otherwise. In conditional statements, P implies Q. P is called the hypothesis or antecedent or premise, and Q is called the conclusion. So this is a special scenario in the case of conditional where P is called the hypothesis and Q is the conclusion. Also, one more thing, this is one of the most important connectives. So just get a clear understanding of this. Now, also conditional statements can also be given as, so one is if P then Q, one is this, the other can be P implies Q, or P only if Q, otherwise Q whenever P, Q is necessary for P, and Q follows from P. Okay, the reason I gave all these other forms of conditional statement is, suppose if you get some statement which is not in the if then form and it is in one of these forms, then you can know. Okay, now example is if I am elected, then I will lower the taxes. So here P and Q can be written as I am elected, Q will be I will lower taxes. Okay, so conditional statement will be P implies Q. If I am elected, then I will lower the taxes. Now, let's see the truth table. If both of them are true, it will be true. In this case, when P is true, Q is false, implication will be false. In all the other cases, it will be true. Okay, you have to remember it as if P is true, Q is false, then the implication will be false, otherwise it is true. I'll continue in the next session. Thank you.